Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us move to the next question. The question number 19. A conductor lies along the z-axis. So this is z-axis, this is your x, and this is your y-axis. Z-axis at z value is minus 1.5 and 1.5. So this is basically lies along z-axis, and this is the length of the conductor. This is the length of the conductor is, this is actually 3 meter, and obviously 1.5 lies above the origin and below the origin of along z-axis. So the length of the conductor is this, and it is less than 1.5. So it is not exactly 1.5. It is little less than that. Not exactly it is 3. It is less than 3. Anyway. So, and carries a fixed current of 10 ampere in minus AZ direction. So current is downward, because this is plus K cap, this is minus K cap. So minus AZ direction. A dash is the unit vector along that direction. So this is direction is taken AZ cap, but because it is downward, so it is negative. We could have put it here minus K cap also, but anyway, it is there. For a field B equals to this something like this, some number e raised to minus 0.2x, so it is exponential, and minus x, so negative value, and negative exponential e raised to minus x type, and ay cap means that is the unit vector along y direction. So the magnetic field is in this direction, as it is shown here. Along this direction, the unit vector is ay cap, along this direction is minus az cap. T stands for the unit Tesla. Find the power required to move the conductor. Find the power required to move the conductor at a constant speed to 2 meter. X is 2 meter. So it is at the origin. Now you have to move this conductor along this line up to this point 2. Since coordinate is 2 here, y equals to 0 m. So it is 0. So y coordinate is 0 because it is lying on x-axis. So y coordinate is 0. So along this x-axis it is moved parallel to that, and in this much time, this is the time taken to this rod from here to here. Assume parallel motion along z-axis. Obviously this is parallel motion because y coordinate is 0. So how much power is needed? So that means if you see, if suppose this is your z-axis like that, so this is brought from origin towards 2 meter. So from here to here you have to do some work. So what is the power that you have to impart to the conductor to carry out this process? Now we have to see, we have to use a formula. What is the concept used here? You have to find the power. What is the power? What is the average power when it is brought from here to here? Because the magnetic field is some variable form. Okay, so magnetic field is not constant. It is not constant. It is some exponentially decreasing functions. So as we move the conductor from here to here, the magnetic field will change. So whenever there is a variable magnetic field, then you have to go for the integration. So the average power consumed formula is that over the time t from here to here, if the time taken is t, then the total time taken and the integration of 0 to t and p at any instant and dt. P dt. If I do that, that will give me the average power. So this average power formula is this. I'll put this power formula from the given informations. I'll write the power formula, then I have to integrate it. That should be in the form of dt. If it is not, then in any other form I have to bring, then I need to solve it. So if I look for power, then how to solve that? Then the power is f dot v. That is okay. F dot v is power, because power is work done by time taken, and work done is the force and displacement in the line of displacement, and dot product, and divided by t. The t you can divide here. S by t becomes velocity, so it is the dot product of two vectors f dot v. So this f dot v you can put here. If I do that here, then what I will get? Okay, let us do that in the next part. F dot v. Okay, let me little solve here so that we will save our time. P dt. This part, what will write? Then P is this one, F dot V dt. Then this is a scalar quantity after dot product. Then F magnitude, V magnitude, and cos of 0. This is FB, FB and dt. So the force, so this will be F, and you can see that V dt is dx, because V is so this is F dot V. Then we have to again use the angle between the force vector and V vector. The object is to move along the x-axis, and this vector, force vector, I have to see in which direction this force is acting. Okay, now this is your current direction, and force acting on a conductor placed in magnetic field is IL cross B. So IL is downward, B is along this direction, B is along this direction. I call this direction as their y direction. This is a y direction. I will place this for your imagination. This is a y direction, this is a conductor, IL cross B, IL, and this is B direction, IL cross B, like that. So this direction is the direction on which the force will act. The force is along this direction, which is perpendicular to both the vectors, so it will be in this direction. So it will be in that direction. This is your I, this is your B, and this is your force. So the force is in the direction in which the conductor has to be moved, because the conductor is placed here and this has to move along this line. So the force direction and the velocity direction is same. So angle is 0 degree. If the angle is 0 degree, so this is no more a vector quantity. This is only F, and this is V, and cos 0 is 1. So this is only dt, and V dt is nothing but your dx, because this has to move along this line, So I'll say at a distance x here, the whatever is the value of and we have to move a little displacement dx. So this how fast or slow this conductor is moving along this direction, that gives you the velocity v. So v dt is nothing but dx, because we know that v equals to dx by dt. This is the rate at which this conductor is moving along this x-axis. So from here v dt is nothing but dx. So therefore this is replaced by dx, so it is f dx. So the p dt factor goes down to f dx. So I'll replace this p dt by f dx, and again this f is BIL, that I told you. F is IL cross B, BIL. So this is ILB dx. I and L are constant is taken out of the integration. If I put here that b is in the function of v is the function of x, and here it is dx, that is integrable, that will integrate. So what we'll do, we will write the formula for average power, that is f, that comes out to be f dx integration 0 to uh, t divided by the total time. Now f is bil, so I'll write bil and dx, and this varies 0 to t. This is 1 by t I'm taking outside because okay. Now because this is in the form of x, so I'll write this in the form of x. So it is in that time how far this will move. So this will move from 0 to 2, it will move. The conductor has to move from 0 to 2. So therefore is 1 by t, I is constant, L is constant, then v dx integration 0 to 2. Then this is I L by t, this will remain as it is, and b is given in the question as b is given in the question as something like b is given in the question as 3.0 10 raised to minus 4 and e raised to minus 0.2x ay. This is the unit vector, there is nothing to do with now. Now we don't have to take this because already we have calculated everything. So this is the value of b. So if I, for the time being, this is of this form, I consider for the time being this is a b naught, this is the maximum value possible, then this b naught into e raised to, this is something like some constant, say this is something like alpha, so this is of the form e raised to minus alpha x, this form, and dx integration 0 to 2. Okay, now if I want to solve, the b naught will also go out, so b naught il, because the constant goes out, by t, and this remains minus alpha x dx. You have to integrate from 0 to 2. Now if I integrate this, because you know that e raised to minus x integration dx is e raised to minus x divided by integration of minus x, that is minus 1. If it is alpha over here, then it is alpha there and alpha here. This is how you do integration. So this will become b naught il divided by t e raised to minus alpha x divided by minus alpha, that varies from 0 to 2. So let us use the next page. So finally what I got is p average, I got as b naught il divided by t, and minus alpha is there, so, and okay, minus alpha right here, minus alpha, and e raised to minus alpha x varies from 0 to 2. If I substitute that value of here to solve it, then it is b naught il divided by minus alpha t, and put this here, e raised to minus 2 alpha minus e raised to minus 0, minus, and put this 0, it will become 0. Okay, that is this is nothing but 1. Okay, this is 1, something to the power 0 is 1, so this becomes 1, and if I take this minus inside, this is 1 minus something, so this is b naught il divided by alpha t, and this becomes 1 minus e raised to minus 2 alpha minus 2 alpha. Now alpha in place of 0.2 I had taken alpha, and b naught it was how much it was? B naught was 3.0 and 10 raised to minus 4. So I'll resubstitute after calculations. That is 3.0, then that is 3.0, that is 3 into I naught is how much is taken? Okay. Where is that question? Current of 10 amperes, so this is 10. Length of the conductor is minus 1.5, so it is 3. So we'll put it 3 here. For the time we'll keep it here. I'll check it out. It's put there. Alpha is 0.2. T is given is 5 millisecond. That is 5 into 10 raised to minus 3. In this time this is happening, and this is 1 minus e raised to minus 2 into this is 0.4. This is 0.4. Now you have to solve this value. Okay, then I will solve this. You know that there is this is expansion series, exponential series. E raised to minus x is 1 minus x plus x square by 2 factorial minus x cube divided by 3 factorial, and so on. This is series, exponential series. So this is in place of x we have got 0.4. So in place of x we have got 0.4. So if I substitute that and solve it, then what I'll get? This is 30 L divided by 0.2 into 5 10 raised to minus 3, and 1 minus of the bracket of. So I'll put here this formula, 1 minus x means 0.4 plus x square, that means 0.16, divided by 2 minus cube of this 0.4 is 4 for the 16, 64 and 0.064 divided by 6, 3 to the 6, and so on. Close the bracket. We'll obviously neglect the higher lower values of this. We can neglect from here, and we can keep up to this, because our answers would be in approximation, so we don't have to calculate all those things. But then if I put that, okay, length of the conductor was minus 1.5 to 1.5, including this and excluding things, but then this is origin, the length comes out to be 3 meter. So I can put this length as 3 meter over here, and what I will get? Now this power comes out to be 30 into length is 3 divided by, this is 2.2 into 5, that is 2 by 10, so it is 1.2, and 25 is 1. So I have only 10 raised to 3 over here, and then 1 there. 1 minus then we'll start from here, the square bracket start from here, 1 minus 0.4 plus 0.08, and the other factors I'm neglecting. Close the bracket over there. So this is 9 and 10 raised to 4. This comes out to 1 minus, this is 1 minus, this is 0.48. Okay, this is actually added to this. This is, if I neglect this, I can do neglect this. If I neglect this for approximation, then because I don't want exact answer as far as the options are concerned, I will have some nearby values, so I don't need this value. To save time, you should always practice this in your exam. Now this is 9 10 raised to 4, and this is 0.6. okay, 0.6, and 1 minus 0.6 is how much? 1 minus 0.6. This is 0.4 again, so 0.4. Then this is 9 into 0.4, 10 raised to 4. And then this is 3.6, 10 raised to 4. Then then 3.10 raised to 4, and that is in 10 raised to 4. How much is coming exactly? Calculation part is in meter, this is in Tesla. 1 minus by 2. Okay, this just so if I see the options there, then it is 2.9 or 3 point something, but then 10 raised to 4 is not there, so we have to recheck the values that we have put. You can see here the value is 3.0 10 raised to minus 4 b value, and what we have substituted here b naught is this, but here I have not used this value, so you have to put this value over here, 10 raised to minus 4 over there, 10 raised to minus 4 over here, and finally 10 raised to minus 4 over there, 10 raised to minus 4 over here. So you put that 10 raised to minus 4 here and 10 raised to minus 4 there. This will cancel out, this will cancel, this will cancel, this will cancel. So therefore it is 3.6, right? Approximately this is the number. If you solve it properly, the options are 2.97 watt, which is approximately 3, right? If you solve approximately, this is the answer. So obviously this will be the choice, 2.97. You don't have to go for exact calculations because it is not required. 3 point something, 3.0. So this is the right answer to this question. Okay, thank you.